Ok, bonjour à tous. Vous pouvez prendre place, hein, prenez votre café, allez-y. Alors, Joe, on a le plaisir de l'accueillir pour la deuxième fois, pour notre deuxième édition. Hein, donc peut-être qu'on fera un grand chelem avec lui à toutes nos éditions. Ce serait un plaisir en tout cas. L'année dernière, on avait parlé avec Joe de sa façon de voir le monde de la data, un peu plus large, de son point de vue qu'il avait en tant qu'Américain, des avancées qu'il pouvait avoir, des différences avec le marché européen. On avait beaucoup parlé des différences, par exemple, sur ce qu'était la gouvernance des données, qui était peut-être un peu moins présente aux États-Unis, se laisser un peu plus de flexibilité dans tout ça. Et cette année, enfin, durant toute l'année, on a un peu discuté. Alors donc moi, je m'appelle Christophe. Je travaille chez OnePoint et je suis notamment en charge avec certains de mes collègues de tout ce qui est data engineering, data architecture, data factory. Et on parlait un petit peu de ce sujet et de la difficulté à recruter des data engineers, des data architectes face à l'opulence de data scientists sur le marché en sortie d'école. Et on se demandait qu'est-ce qui s'était passé finalement pour qu'il y ait autant d'apprentis data scientists sur le marché et si peu de data engineers, alors qu'un projet de data, c'est peut-être, allez, je vais être chauvin, 80% de data engineering avant de pouvoir utiliser la donnée. Et on s'est dit qu'on en ferait un sujet. Si vous êtes data scientist, bouchez-vous un petit peu les oreilles, on va avoir un petit peu de trash talk. Et on va essayer de comprendre un petit peu quel est le rôle aujourd'hui de data engineer, pourquoi un data engineer c'est important dans un monde moderne. Et Joe, I will let you do the talk. I just introduce you.
I have no idea what you just said, so thank you.
Donc on va avoir des slides en anglais qu'on va diffuser, très simple. Si vous avez des questions, n'hésitez pas. S'il y a des, je vais demander à Joe de parler lentement. Si jamais vraiment c'est trop rapide, levez la main, dites-le, n'hésitez pas, on ajustera le débit. If you can speak slowly, please.
Well, so if I'm talking too fast, just tell me to do that. So just press this button and go. Yeah. Okay, look at that. All right. Hey, all right. So we're going to talk about data science and data engineering. I have to sit over here so I can see. I can't see behind me. I'm trying to develop that talent, but I don't have it yet. So I wrote a book. I call myself a recovering data scientist. We will talk about what that means in a bit. I also travel the world giving talks. I write books. I still work as a data engineer and a data architect. And I do a bunch of other stuff you can read right there. What you'll learn. So we'll cover a short history of data science. I think you might find this interesting. It's not the history you might be thinking of. Then we'll get into where data science succeeded and maybe where it could have done better. And then we will talk about data engineering. So data science, I would like to ask, and you can ask and then translate for me to the audience, what do you think a data scientist is?
Qui a envie de répondre sur sa définition du data scientist de nos jours? Est-ce que quelqu'un veut se lancer? N'ayez pas peur.
The unicorn, I think. Anyone else?
Someone that makes models.
Someone makes models. A unicorn that makes models. Anybody else want to take a stab at that? Yes.
I would say a glorified statistician.
A glorified statistician. Yeah. Okay. Well, that's fine. That's fine. Don't worry about it. What do you think about that, Hala? She's actually a math professor sitting here. So
I knew you were going to ask me. I feel like only when you have a clean and complete data set, then you can start doing a data science. So you have to have the underlying infrastructure first.
Okay, and this is Hala Nelson. She wrote O'Reilly's Essential Math for Data Science, or AI, I think it was, or yeah, anyway. Awesome. So, yeah, great answers. Thank you. It turns out that there's a lot of definitions of data science. This is one of the early descriptions of it from 2013 by Drew Conway. So it's the intersection of what he calls hacking skills, so just being able to use a keyboard productively, a computer, math and statistics knowledge. Back in the day, this was called machine learning. I guess it could be a lot of stuff now. Then substantive expertise, so domain expertise, I think is what you would call this. So people who are well-versed in their businesses, right? I think that how often have you seen hired a data scientist who knew nothing about your business, but thought they would do great things because they're unicorns?
La question, vous l'avez comprise, c'est combien de fois est-ce que vous avez embauché un data scientist qui comprenait rien au domaine métier pour lequel vous l'avez embauché?
Yeah, happens. So this is one definition. And as I started digging into this, and so I've been around the block. I was doing all this stuff before it was called data science, because I'm really cool like that. And this was the article that came out in 2012, where data scientist was the sexiest job of the 21st century, by Tom Davenport and DJ Patil. And this, I think, if you weren't a data scientist then, but you were doing data science work, now you were a data scientist, because why wouldn't you want to be the sexiest person of the 21st century, or have the sexiest job? Sorry? Oh yeah, it totally is. I wish. So then you kind of fast forward, and then you realize that DJ Patil, so him and this other person, Jeff Hammerbacher from Facebook. So DJ, I think, was at LinkedIn, and Jeff Hammerbacher was at Facebook. And at the time, in around 2009, when they came up with the term data scientist, this was around the time of the big data era. So data was growing in the 3 V's, the velocity, variety, and the volume. And they needed a way to find out who this person was that would deal with it, right? The traditional statistical methods were on usually small data sets. Now you had large data sets because you have social networks. Data sets grow. And then you dig into, fast forward, and then you start realizing this quote here, and it's sort of in the subtitle here. But I think the fundamental reason data science took off, I'm paraphrasing, is because people aren't really sure what it means. And that's the power. Right? So we dig further into the definition and why it came about and the history. That's DJ Patil. He later went on to become the first, and I think the only chief data scientist in the White House, the American White House. And then, this is interesting history. I don't expect you to read this, but what he's saying basically is there were a lot of people with data in their titles, and they weren't trying to create a new field, but they just made up the title to keep HR off their backs. So this is what gets interesting. And then, you know, people started applying for these jobs, right? And then this led to the Harvard article. And then just more history on this real quick. You know, they come back with this article in 2022 about, is it still the sexiest job of the 21st century? Well, of course, if you write an article on something and then 10 years later you're going to talk about it, you're probably going to say, yes, it is. And the article goes on to explain why it is. And there's some great points to it, right? I think that what happened over the 10-year time frame is that data became sort of integrated into every business. Right? When I got started in data, and I'm sure that anyone who's been in the industry for a while, data was not sexy. It was actually very uncool. Like, you were kind of a dork. So that's what data was. But this popularized it, right? And so a 10-year reflection. I think there's another slide here. Well, we'll get into this. But yeah, so past roles really used to be statistician, right? Used to be business analyst. Data, or do you say data or data here? Data? Okay, thank you. I just wanted to be sure. Depending on the country I go to, I always get yelled at for the wrong thing. You know, BI developer, business intelligence developer, operations research as well. Who's ever heard of operations research or has done it, right? So I think this is actually old school data science, and it works really well. But then you started lumping on all these terms into data science, right? So, and here's some things I noticed back in the day, because my background's in like operations research, statistics, and machine learning, and this goes back way back like 20 plus years. But back in the early 2010s, when data science was becoming cool, analyst became a 4-letter word. You were very uncool if you're an analyst. All of a sudden, if you were a data analyst, you did everything in your power to become a data scientist, because you could make more money, for one, and two, your friends would laugh at you and not hang out with you because you're not one of them anymore. I remember hearing that SQL was going to go away, that nobody was going to use SQL because of big data, because of Hadoop and MapReduce and all this stuff that you weren't going to need, business intelligence was going to go away, data warehousing was dead, SQL was on the way out, right? Ironically, many of the tools created at companies like Facebook were meant to address the shortcomings of tools like MapReduce. So you talk about Hive, right, which is SQL on top of Hadoop, and then Presto and so forth. So it's ironic that, well, everyone's saying this, they're building tools that led to the next wave of data infrastructure. And around the mid-2010s, data science started incorporating analyst titles, for example, right? So there were, I think, as far as I remember, analyst titles were dropping off because everyone was now a data scientist. Mind you that that nobody ever actually defined the title to begin with of data scientist. But then if you talk to hiring managers at companies and you talk to employees, everyone wanted the data science title because it means more money. It means prestige. It means you can keep the 5 friends you have left because you were still an analyst back in the day. So, and now you fast forward to today, and data science means everything, right? I think that there's not a day that goes by I don't see the term data science at least 1,000 times a day, or something like that. So, so we can talk about where data science succeeded and where it failed. Data science succeeded, I think, in that it really helped bring data to popularity. If you can remember, again, back before the data science and the big data push, companies weren't fully leveraging data, right? I mean, it was IT was BI, business intelligence was basically an internal IT function. It was all about internal reporting and internal insights, if anyone cared about that. Most things were done in Excel, right? And they still are, actually. Excel is still the most widely used data platform in the world by a long shot. But, so I think the article is like that Harvard Business Review with the data science being the sexiest job of the 21st century really brought data into the limelight. Now suddenly every company has to be doing data, or else they'll... Tell me if this sounds familiar. You had to do data science because if you didn't, your competitors would move faster than you. Who's heard this about 5 times today, at least? Right? Who hears this from every company? Now it's AI, right? Like if you're not doing AI, everyone will move faster than you. We'll get into why this is relevant to this discussion in a second. But businesses finally prioritize data. Right, so for better or for worse. I remember in the early 2010s, every company had to do big data, even if they had like megabytes or gigs of data. So everyone was doing Hadoop on these pretty small data sets. But that was because you wanted to have the optics of hiring people into your company. Like nobody, everyone wants to say, oh, well, they're doing Hadoop there on like 1 gig of data. But it didn't matter, right? Because you got to get exposed to these technologies. And this is awesome in a lot of ways. I feel like this brought forth millions and millions and millions of students getting interested in data for the first time. I, for one, was thankful because it meant that I could make more money finally. Like I could get a pay raise. So, which didn't happen before, because it's like you're the data person, they'll stick you in the basement and have you work down there. It changed, right? Data science, I think, was the highest paid profession for a long time, highest paid career path. Boot camps arose and new crops of data people came out. We'll get into why I think that's good and bad in a second. But this also meant better tools and technologies and techniques, right? Especially in machine learning, which I suppose is now called AI, but it's still machine learning. So, and what I mean by this, well, back in the day, hardware was really hard to get, right? So we would have to rip apart old Xboxes for the graphic processing units to do matrix multiplication, and then your computers are pretty bad. NVIDIA, if you've heard of them, I think took advantage of the big data wave and with CUDA, and so the hardware kept up, new techniques kept up, right? So deep learning comes around about 2013, 2014, maybe in 2012, but whatever. But it became very popular, and that meant like the rise of deep learning and everything else meant that data science just took off. I don't think so. You're talking about a once in a generation event. I don't know that this could be replicated ever again. it's reasons like Python as a language took off, right? Python's actually a pretty crap language in my opinion, but it got popular because it was just everywhere, right? And so the rise of deep learning and everything else, I think, made that the world's now the most popular language in the world according to the TIOBE index. So it meant a lot of cool things happened. I think where it failed, and it's a victim of its own success, but there was a lot of hype, right? Everyone has to do data science. Everyone wants to be a data science. I think even my grandmother, who was 80, was like, what is data science? And I had to, I'm not kidding you. She asked one day, and I was like, I explained it, and she's like, oh, well, that's neat. So, and then, again, the failure rate of data projects wasn't resolved. I mean, I think historically the number's always been quite bad with IT projects in general, right? Data projects, I think the stat hovers around 80 to 90% failure rate. And I think the expectation was if we hire, say, a PhD or a bunch of PhDs of a math program, like Verhala teaches, and then they become data scientists at my company, magical things will happen. Unicorns will rise, and I think people found that to be a very expensive mistake, right? They mistook the technical competence and the knowledge and the skills of these, these wonderful math PhDs and physicists and so forth, with the ability to solve business problems. And we're going to get into why this is important in a bit. And data science became very diluted. As I say, if everyone is a data scientist, then nobody is a data scientist. And I think that's very true today. I still don't know what it means, even after the wonderful descriptions from the audience of glorified statistician, model builder, unicorn, and so forth. I still don't know what it is. I don't know that I ever will. I don't know that any of you will either. And that's the whole point. So let's talk about something else here. I'm sure that everyone, so these are some stats. This came out in, this is one of many articles that always talks about how we could do better as an industry in terms of success with data. There's this old Gartner number at the top here. 85% of big data projects fail. This was in 2017. I'll tell you why this number is kind of funny, actually. 87% of data science projects never make it to production. This is true. Through 2022, which was a while ago, only 20% of Analytics Insight will deliver business outcomes. As far as I can tell, these numbers haven't changed at all. At all. The Gartner number is interesting because this was actually a projection that they gave, where they said, by the year 2022, 85% of data science or big data projects will have failed. But everyone took this number and just ran with it and said, oh, well, obviously they all fail, right? So the only way you can succeed is if you either buy my product or hire a data scientist. And then 87% of data science projects never make it to production. I've seen this. How many companies have tried data science or AI initiatives and still have them in proof of concept or POC mode? Right? I think this is common. It's called.
I don't think anyone will admit to that question.
You don't have to raise your hand. Just blink twice, like that. Gotcha. So this was, this is, I think the dirty truth is this, and we're going to talk about why this is important. And then analytics is this interesting one. Insights is always something that's a term that's bugged me because I think the expectation of data scientists was they will come in and dig through our data and then find insights, right? Kind of like a gold miner, like panning for gold in a river or something, and like it might happen. I actually had that happen once, but I'll leave that for later. I got 2 patents out of doing that. I'll tell you real quick. So we had, I was working at a startup. We later got bought by WeWork, but if you know all those iPads that are on the conference rooms, we made those. And we were selling to companies, all the big tech companies, Twitter, Netflix, a lot of Bay Area. And at the time, people would reserve conference rooms and never use them. And in these big cities, office space is very expensive and there's no room. And so I kept noticing people would basically reserve conference rooms and never actually attend the meetings, but they would just reserve them for infinity. And what resulted was a patent called Ghost Meetings. Actually, I have 2 patents on this. And so it was just the insight that if meetings keep doing that, then just cancel them. It seems obvious in retrospect, but this happened just because I was one day stumbling around and found it, right? So that can happen, and that was interesting, but doesn't always happen. Right. So then I got really cynical, and I started writing these articles in 2018, 2019 about data science. This was really a cry for help. But at the time, I kept feeling like data science, it was great, but I really felt like it was not achieving its potential, and I felt like it was overhyped. And so I started writing these articles, and they got pretty popular. This is on my old blog, josephreese.com, which still exists with a bunch of terrible blog articles like these. And then I wrote this, What is a Recovering Data Scientist? Because me and my friends, we had this title for ourselves, so we started calling each other that. I believe I was the first one, but anyway. So I think that around this time I noticed other people were doing this too. We started, I think, questioning the value of data science and what it was really bringing to the table. Because I think almost 10 years into it, we hadn't seen significant movement or impact like you would expect from the sexiest job of the 21st century, right? So I'm not so much convinced that this is where I put dead in quotes in my beginning title. I think that what I mean by data science being dead, it's always been meaningless, and I think it's succeeded, but the term needs to eventually go away. I don't know how that will happen, but it does need to go away. Again, it never was meant to be anything. It means a lot of things, and it seems like everyone's a data scientist, and I still, again, me or nobody really knows what that is. So talk about data engineering, which I think is a bit more concrete. So again, we'll look back on data science failures, right? Notebooks and POC purgatory. Data in the real world is very messy, as Hala was saying, right? Data science education mainly focuses on tactics and not how to work in production. So this is why that statistic of 87% of data projects fail to make it to production. We'll get into why this is. Who's seen this? This is the Data Science Hierarchy of Needs by Monica Bragati. I think it was published in 2017. But the promise is that we focus on the top part of the pyramid here, right? So, whoops. Meanwhile, if you look at the bottom, this is all the stuff that you really need to put things into production to make data science work. But we're focused on the hot stuff here, AI and deep learning at the time, because that's what people are going to pay for, right? Nobody wants to pay for this stuff down here. Well, now they do, because they realize it's necessary. But for the longest time, the expectation, I heard this from CEOs, chief information officers of companies of all sizes, that we just need data scientists and things are going to happen. Things are going to happen. Turns out things didn't happen because you ignored the foundation. This is around the time I got into data engineering. I think it must have been 2015 or 2016, because I kept noticing over and over, I was hired to do the top, and the bottom was missing. So I ended up just building the bottom, and that's how I became a data engineer. It wasn't because I felt data engineering was going to be the next sexiest job of the 21st century, but I felt it was going to be a necessary job of the 21st century. And it turns out that was true. So motivations, and I ended up writing a book on it, right? Because I love the field of data engineering so much. And around the time, data engineering wasn't well defined or understood. I don't think there was a standardization of skills or knowledge. Way too much focus on technologies. Vendor marketing was cranked to 11. That's an old reference to Spinal Tap. And the big question, is what wouldn't change in the field of data, where everything seems to change every 5 minutes. So, and as an example, right, there's also a lot of noise. Who's seen this before? Who's squinting right now, trying to see it? So this is my friend Matt Turk. He runs First Mark Capital. They're a venture capital firm in the US. But this is basically describing all of the companies or open source projects within each vertical. So if you squint really hard, data governance and catalogs, Ole's favorite topic, there's a lot of them. And there's 1,400 plus logos on this slide. If you look closely, you can even see my company there. So, you know, because I matter. But Matt told me that this is about 1/2 to 1/3 of the total logos that they had surveyed. Everything changes, right? How do you keep on top of all this noise? And so one thing we wanted to focus on is data engineering, and because due to time all. So wrote this book, and I think, as far as I can tell, it became the book for data engineering, so I've heard. But what we wanted to do is define things from first principles, right? I didn't want to fall into the same mistake of data science, where nobody actually defined it, and they just kept running with it. Here's my very long definition of data engineering. I'll let you read that for about 30 seconds. I'll give you the short version. You get data and you do something to it, and then you give it to people. So that's what it is. But that's about it, right? But I think before then, we were, as an industry, hard pressed to put a name on something. So I felt one of the things that I wanted to correct with data engineering was actually formalizing it as a discipline versus just coming up with the 1,000th first tutorial on data engineering with Spark or something like that. So why data engineering? Why does it matter? And why should you care? There's a lot of focus on data, again, because of AI. It seems that every company a few years ago wanted to be data-driven. Now every company wants to be AI-driven, right? If you're not AI-driven, let me see here. Competitors will move faster than you, and you'll be outrun by the competition. Have you heard that before? There's also a movement called data-centric AI by my colleague and friend Andrew Ng, which we'll talk more about in a bit. And then data engineering, it builds the foundation for AI and machine learning and analytics and so forth. I know this through experience, and this is just, if you go back to that hierarchy of needs, it's very true. And so it's necessary. It's always been necessary, but for the longest time we skipped over all the steps. But now people are making the investments into data engineering because they realize that without the foundation, this will all not really work too well. Some interesting, I think, revelations on this. My friend Kostas wrote this article, ML Ops, Machine Learning Ops is 98% data engineering. I do agree. I'll let you read the title. There you go. Okay. And here's some quotes by Andrew Ng. The discipline of systematically engineering the data needed to build a successful AI system. This is what he means by that. All that progress in algorithms means it's actually time to spend more time on the data. And this is being borne out. When you look at large language models, for example, empirically, the trustworthiness and the stability of your large language model depends on the underlying data set it was trained upon. You cannot escape this. This is how it works. You can do things like RAG to introduce new things to your data set, but the thing is, it's only as good as the data is trained on. This has been the fact of machine learning and analytics from day one. We've never been able to escape this. The caveat to this is when you have AI-generated data and synthetic data, I'm very curious to see where this goes. I think, what was it, 90% of data on the internet by 2025 or 2026 is supposed to be AI-generated synthetic data, not human. So I'm not sure what this means. But for now, well, I know what it means. You'll just train on synthetic data, and it'll just be like exactly that. But this isn't to say that I think data engineering is immune from also having changes to it right now. There's the notion of a data platform engineer, which I think you're fond of, Christoph. Data product developer, which is a title that our friend Zhamak Dagani, she created Data Mesh. I talked to her. Last year I had to give a talk about why Data Mesh would do away with data engineers, and I had to take the side that it would. So I just asked her, what do you mean by that? And she said, well, you become a data product developer at some point, right? Because there's the boundaries of software and data and machine learning sort of converge. And I think this is actually what's going to be happening over the next decade as we move away from internal-facing IT and BI towards external-facing analytics, machine learning, and so forth, where data is the product. This actually makes a lot of sense. AI platform engineer, I actually think this is going to be the new sexy title of the 21st century. It's the recognition that while data is awesome, people are going to want to change the title to AI. It's as simple as that. And then, or you can take X plus Y engineer/developer and make up your own title at the bottom. That's also how it goes. But yeah, I think, again, data engineering, it's always been there. It's always been the foundation. I think it was a matter of time before it got recognized. And again, that's what I meant by the title of the talk, data science is dead, long live data engineering. And wrapping up, data science succeeded, but again, I think it's time to move on. And data engineering is awesome. And that's me. You can add me on LinkedIn with my QR code, or if you don't want to do that, you cannot take the picture of it. But I also have a really good Substack called Practical Data Modeling. It's my new book that I'm coming out with. And it's actually, I think, the world's biggest community on data modeling right now. So we talk about nothing but data modeling because we're super exciting people. So,
Because we're super nerds.
Yeah, well, it turns out data modeling is also important. What I find is interesting is all of these old topics, the really boring stuff, modeling, engineering, infrastructure, catalogs, right? Really boring. Totally boring. But this is what's becoming popular because people are realizing this is what is necessary to make AI work, right, in production. My question, I always ask this question to audiences around the world, and then you can start asking me questions. But who today would put a large language model on top of your corporate data systems?
You can blink if you want to answer that question.
I don't know if they didn't understand me, but yeah.
How many of you want to add AI Gen to your current company infrastructure as a solution to the data issues you're facing, without questioning your data, the data modeling and stuff? Yep. I think that's Joe's question.
Yeah. Nobody ever, huh?
Most.
What's that?
Yeah, most companies would like to add AI to their stack.
But my question is always, would you, if you were to do it today and you were also to bet your job on it? Nobody's ever answered. Nobody said yes. And this is probably, I think, in front of thousands of people at this point. So anyway, that's the question I always end with. Why are things like this important, right? So I can take questions, though, if you'd like to ask them.
Vous avez des questions, je peux les traduire aussi si vous voulez les poser en français. Okay.
And you can stare at my really terrible picture for the next 5 minutes.
Puisque tu traduis, if you translate, I take the action.
Yeah, please.
So sorry, question in French, I translate after because it's better. Ça fait des années qu'on parle un peu de ça. D'abord en petit comité, puis de plus en plus aujourd'hui, ça devient presque une évidence dans la salle de dire que le métier de data ingénieur est important et qu'il y a une masse de data scientists. Ma question, c'est pourquoi dans les écoles, on continue, françaises, et je ne sais pas si c'est pareil aux États-Unis, j'aimerais bien qu'on lui demande, on continue à former des brouettes de data scientists qui galèrent à trouver un premier job. Vraiment, j'insiste, qui galèrent beaucoup à trouver un job.
All right, so the question is, we have been talking about data engineering as an important role for a while now. So why do boot camps in schools still offer courses on data science and deliver data science junior data scientists on the market with bucket loads?
Yes. You're starting to see, I think it's because education lags behind industry. So imagine the first data science degree or boot camp. That was, I think the first one I saw was 2014, 2013. But like, you're starting to see this with data engineering. My book is being used, I think, in every university now. And they're starting to have classes and programs. They may have degrees at some point. I think it's a bit of a difficult degree to think about. I am personally working with Andrew Ng on a 16-week specialization for Coursera on data engineering. So I believe this will be the first of its kind. And we expect this will be possibly one of the biggest courses ever on that platform. So I think it's slow, for sure. Yeah, but Andrew's first course, I think, was 2010 or 2011 for machine learning, and that was the first MOOC, right? And then that spawned, I think, a lot of interest in machine learning. But there was not a similar thing for data engineering. I think it's part of it. Yeah, I wish there were more. But...
Je vais te faire une réponse en français, Philippe. On en a parlé tout à l'heure avec Joe. I'm going to talk French because we talked about that earlier. But il y a 3 ans, j'ai fait ce constat-là. J'ai une responsabilité chez OnePoint, c'est de recruter beaucoup de data engineers. Donc j'ai fait ce constat-là, que j'avais beaucoup de CV de data scientists qui venaient cogner à la porte, 200, 300 par an, facile. Ce que j'ai décidé de faire, c'est de créer un master en data engineering. J'ai conçu avec beaucoup d'autres personnes de chez OnePoint un programme de 300 heures. On l'a soumis à une école. J'espère qu'il n'y a pas de représentant de cette école ici parce que je vais peut-être pas bien en parler là, mais donc on a soumis le master. Ça fait 3 ans que le master existe. On avait un programme de 300 heures focusé sur le data engineering. Petit à petit, on m'a demandé d'enlever des cours un peu trop data engineering, un peu trop informatique, un peu trop nerd, pour ajouter un petit peu de cours de Python plutôt que de Scala. De machine learning plutôt que d'Ops, etc., etc. Et au final, pourquoi? Parce que sur un site web d'une école privée, avoir le mot intelligence artificielle, avoir le mot data science, voilà, ça fait vendre le cursus. Donc aujourd'hui, c'est quelque chose, mais c'est aussi notre responsabilité de faire en sorte de rendre notre métier plus sexy pour qu'il soit vraiment... pour que les gens qui viennent sur les sites des écoles aient envie de prendre le parcours data engineering plutôt que le parcours intelligence artificielle.
If anyone wants to write a Harvard Business Review article with me about why data engineering is the sexiest job of the 21st century, I will help you with that.
So
and we will become famous.
Okay, challenge accepted.
So I kind of feel like what you've shown to us today was that data in the virtual world, so in the software world, is very fluid, and in the real world, it's just as fluid. It's changing constantly. Actually, deep learning was invented, a long time ago, and the term deep learning kind of went into this, the back corner. No one wanted to talk about deep learning, and then we talked about machine learning, and now we're talking about AI. It's all the same thing,
yeah.
And things are quite fluid. So the term data scientist was a big thing. And now we're talking about data engineering. You talked about a data product developer. I even consider myself as a data product owner, which doesn't exist yet it's a term that we could define for project managers that manage data projects. So I feel like in what you've presented here, actually some of the interventions we have, the conferences we've had, we've talked about regulations and so on, what we're realizing is that the challenge that society is facing as a whole is data itself is extremely dynamic, very fluid, changing constantly. And we as a society are trying to create rules to define it, definitions to understand what it is, yet in itself it's constantly changing, and the definitions and the words we're inventing today are not going to be the same in the years to come.
Correct. Everything changes quickly. So I don't know where it goes, but actually I do know where it goes. But yeah, I think you were going to ask me a question earlier, though.
Yes, I had a more specific question, actually. Yeah. One that was commonly asked in terms of culture to me as a French American, but I'm asking you as a data engineer who has the perception of what's going on in the US compared to what's going on in France. Can you give us an idea of your perception of this reality of data engineering and AI across the Atlantic Ocean?
It's interesting. So I spent the last year and more in Europe quite a bit, and I'm from America, obviously. and I spend a lot of time with American practitioners and companies. So I think I have a good understanding of the two geographies. It feels like Europe moves a lot slower, and there's, I would say, and I think that's a good thing and a bad thing, right? I think, actually after the conference here, somebody came up and pulled me aside and said, Joe, I think you need to realize that the US innovates and the EU regulates. And that has stuck with me for a long time, including coming back numerous times, is that I felt like that's a really big distinction. And the U.S., it's. I think a lot of it is just the mentality of how we approach business and problems and how we, and use technology. It's sort of do things first and ask questions later, and things move in just a much more rapid cycle than they do here, it seems. And so, but I don't know that it's a bad thing. I think that there's quirks, or the consequences of that mean. There's we sort of figure it out after the fact in the U.S. that things may not be a good idea, whereas I think if you move more slowly, so like from a practice point of view, things like say data modeling, for example, right? I feel like Europeans have more of a chance to focus on that, whereas in the U.S., a lot of practices like modeling, architecture, in the traditional sense, have sort of gone by the wayside, because everything moves just very, very fast. And so I think that's the biggest cultural difference, is just the speed.
So like the US is ahead of the wave, and France is still part of the wave, but not going through all the, I guess, all the mistakes and errors. We kind of take advantage of the fact that the US has already done them for us, but it also makes us a little bit behind.
You can send us a thank you card later. No, it's interesting, and like on my podcast, I've had on was it Kai Zenner? He was one of the architects of the EU AI Act. But it's interesting getting the perspective of that, where they were trying to preempt or get ahead of AI. In the US, I don't think we'd ever try and do that for a lot of reasons. So,
you have a question from the...
Yeah. Hello.
Hi.
I would like to know, do you think you can confidently say that US companies are gaining competitive advantage globally because they are steaming ahead with this?
I can't say that definitively, no. I mean, and I think there's some interesting things happening in France. Like Mistral, for example, I think is it put data and AI on the map for France, as well as FAIR and other things here. They've been here for a bit, but it's like, so I can't say that the speed is the only attribute, but I think that's a main. I think it's a big attribute. I would say it's statistically significant. Yes, and obviously different cities in Europe are different, and different countries are different. So like I'll tell you, like even when I talk about data modeling, I notice there's pockets in Europe where it's very rigorous. If you go to Finland, for example, or Bavaria, it's like data modeling is very hardcore there, right? Other places, not so much. So I think a part of it is culture, and I think there's a more nuanced culture that's just been historically here, whereas in the U.S. it's a young country, and the main thing is just, move fast, break things. It's like...
Thank you very much.
Yeah, hopefully I answered your question, but yeah, I don't think speed universally is the only thing, no. But it matters.
Thanks, Joe. We're going to have to wrap things up.
Yeah, thank you.
Thank you, Joe.